Cooling and heating effects from earth tube. Heat exchanger. Abstract. Before understanding the concept of earth tube heat exchanger. Let us first understand the concept of heat exchanger. Heat exchanger is a device used to exchange the heat between two fluid at different temperature. Earth tube heat exchanger is a new innovative technique used for cooling and heating in summer and winter respectively. Here the cooling and heating is achieved by utilizing the temperature difference of fluid present at inside and outside the Earth's surface. Further, this method of heating and cooling is free from hazardous effects of global warming and ozone layer depletion. The performance of earth tube heat exchanger depends upon various parameters such as length of pipe, pipe diameter, depth of burial of the pipe, airflow rate and different types of soils. Keyword earth tube heat exchanger. Alternate method of heating/cooling, blower, temperature sensor. Introduction. The concept of earth tube heat exchanger is a new innovative technique currently being used for cooling and heating of a building or room during summer and winter respectively. The modern approach of heating and cooling is based on vapor compression cycle that utilizes refrigerants such as chlorofluorocarbon, CFCs, and hydrofluorocarbon, HFCs. These refrigerants are very toxic, causing global warming, uncertain climate changes, acid rain, and depletion of ozone layer. Further, the conventional system also consumes large amount of electricity. These concerns have motivated us to design an earth tube heat exchanger which is free from environmental pollution and require less energy consumption. It also has vast application not only on domestic usages but also on agricultural usage, say for cold storage of vegetables, and industrial usages. Though this system is not as efficient as conventional system but offers lower running cost compared to conventional system. 2. Classification of earth tube heat exchanger. The earth tube heat exchanger is basically classified into two categories. They are A. Open loop system. B. Closed loop system. A. Open loop system. In open loop earth tube heat exchanger, the surrounding air is compressed and is made to flow inside the tube buried into earth, where heat is exchanged between the surrounding air and earth soil, and then the air is made to pass for heating/cooling to a room or building. B. Closed loop system. In closed loop earth tube heat exchanger, the surrounding air is used in a closed cycle for carrying out the heating/cooling of a room or building. Fig. 1 Open loop system. Fig. 2 Closed loop system. 3. Literature review. N.K. Bungsal M.Sodetal 1 told that ETH can be used in an alternate of conventional air conditioning system. He also suggested that the performance of ETH depends upon thermal conductivity of soil, increase in the length of tube, decrease in pipe diameter, decrease in mass of flow rate of air, and depth of tube buried inside the earth. Nilesh Escheller et.al. In his study, it was found that higher velocity of air causes less temperature difference between inlet and outlet of pipe. So, velocity of air should in between 2 to 5 m/s for a good performance. Kunjay M. Chauhan, et.al. 3 in his research, an analytical model was generated where he took a PVC pipe of length 113.29 m having diameter of 0.15 m and inlet velocity of 4 m/s, was able to achieve a temperature drop of 140 C, which shows that the system is useful. Sirajeldin et.al. 4 conducted an experiment for thermal performance of ETH in Egypt using 3 different types of pipe materials, i.e. PVC pipe, steel pipe, and copper pipe, and found that outlet air temperature in case of PVC pipe is 19.60 C and that of steel pipe and copper pipe is 19.80 C. This suggests that outlet air temperature difference in case of PVC pipe, steel, and copper pipe is of 0.20 C, which is very small and can be considered as negligible. 4. Experimental setup and its working. The earth tube heat exchanger consists of following components: I. Blower 2, PVC pipe 3, temperature sensor 4, exhaust fan. I. Blower. A blower is a device that is used to pushes the ambient air by imparting energy to increase its pressure and speed into PVC pipe. 2. PVC pipe. PVC pipe is a tubular section, or hollow cylinder made of polyvinyl chloride in which the ambient air is made to flow. 3. Temperature sensor. A temperature sensor is a device that detects and measures hotness and coldness and converts it into an electrical signal. 4. Exhaust fan is a device used to ventilate a room or a building. This helps to bring fresh air from earth tube. Working principle of earth tube. Heat exchanger. The earth tube heat exchanger works on the following principle. 5. Because of diurnal cycle of air temperature and solar radiation, the temperature at 2 to 3 deep inside the Earth's surface remains constant throughout the year and varies about 10-150 C from Earth's surface temperature. I.E. In summer the Earth's surface temperature is greater than 10150 C and then temperature at deep of 2-3 M and vice versa. In winter, the temperature at deep of Earth also varies according to climatic condition of the soils and its thermal conductivity. Utilizing the above idea, in this experiment a PVC pipe of length 10 m is taken having dia of 0.10 m is placed at 2 m deep inside the earth in a horizontal position. A blower is used at the inlet of the pipe that pushes the ambient air by imparting energy to increase its pressure and speed inside the PVC pipe. The ambient air is made to flow across the length of pipe. And there occurs exchange of heat between the air inside the pipe and deep earth surrounding due to temperature differences. Fig-3 Earth Tube Heat Exchanger. 6. Observation. While performing the investigations following observation have been made. In summer the temperature at inlet of PVC pipe measured from temperature sensor is 360 C and temperature at the outlet of pipe is measured as 250 C. In winter the temperature at inlet of PVC pipe measured from temperature sensor is 180 C and temperature at the outlet of pipe is measured as 280 C. 7. Advantages. The working fluid is air which is easily available and free from environmental pollution. Design and installation both are simple. The initial setup cost is less compared to conventional air conditioning system. This system does not involve any type of combustion and hence it is free from pollution and greenhouse gas emissions. 8. Results and conclusion. Earth Tube Heat Exchanger is novel alternative for air conditioning in a clean and inexpensive manner. Further, this experiment give way some discoveries regarding the performance of Earth Tube Heat Exchanger that are mentioned below. The temperature at the 2-3 m deep of Earth is constant throughout the year and varies almost 10-150 C from the Earth's surface temperature. I.E. In summer the Earth's surface temperature is greater than 10-150 C and then temperature at deep of 2-3 m and vice versa in winter. The performance of Earth Tube Heat Exchanger depends upon length of the pipe. Increase in the length of pipe increases the performance of earth tube heat exchanger. Velocity of air inside the pipe. Decrease in the velocity of pipe increases the performance of earth tube heat exchanger. Diameter of pipe. Decrease in the diameter of pipe increases the performance of earth tube heat exchanger. 9. Applications. Earth tube heat exchanger can be used for air conditioning of residential areas, corporate offices. Earth tube heat exchanger can be used for cold storage of agricultural products. Earth tube heat exchanger can also be used in industries to preserve certain things. Future scope. Earth tube heat exchanger has got the potential to replace the conventional system of air conditioning in future. Further, it also reduces the release of harmful gases such as chlorofluorocarbon, CFCs, and hydrofluorocarbons, HFCs, into the atmosphere that causes global warming and ozone depletion. Also, the system of heating/cooling is leading a path to a know of researcher in the field of conservation of environment. Acknowledgement. I would like to express my sincere thanks and gratitude to Mr. Ravi Pratap Singh, Assistant Professor, Department of Mechanical Engineering, Institute of Technology and Management, Gita Gorakhpur, for being great source of inspiration and pleasure and providing constant motivation to present the paper on design and fabrication of earth tube heat exchanger. I am also thankful to my team who stood by myself in every situation and constantly supports me in writing this paper.